Welcome to the last module of this course. So we're going to have a lot of fun here. We talk about all the process, using the tool to measure, share with you all the major principles and strategies to make your app run faster. And now we're actually going to look into a casual game, our case study. We're going to actually apply all the things that we've learned, and then we'll try to see if we could make an app run faster. Okay, so again, this is a casual game, performance tuning. Okay, we're going to actually get started with. All right, first of all, obviously, we're going to share with you what is this casual game. You know, hopefully you really have some fun by playing with this game. And then we're going to apply all the things we learned, right? DJ talked about how to do memory allocation, stay lean, use less memory. That's something we want to look into. And we want to also talk about how we could actually use fast objects and play with that and do fast manipulation. That's another thing we want to look into. And do less work and know what your application is doing. This is another one really, very useful for this particular tuning. Okay, so casual game. What kind of game we have? I want to thank you for the Chakra team. They actually had a wonderful benchmark kind of game called High Five game. I don't have to explain what's a High Five game, right? It is a single player kind of game. It's a single page, and it's very casual. So first thing is I want to show you what is this game, right? So I actually loaded a copy of code in Visual Studio already. So we could actually run this particular game. Okay, let me actually, hear the nice music. Okay, let me change it a little bit. Okay, so you know the music, let me actually turn down the volume a little bit. Because, after you try to tune this app many times, you probably, get a little sick of the music. Let me turn it down. Okay, but basically, this is a high five game. I touch any of the players in the game board, that particular person is going to do a 90 degrees rotate, right? And it will actually hit the neighbor, right? And the neighbor is going to do the rotation again, and until that list is finished. So you could actually see different scores. Okay, so let me actually turn it off. You heard enough music of that. Okay, so this is the initial game board, right? And then obviously, if you could actually increase your game board towards the largest, and I could even say I want to actually do some benchmark onto it, right? Okay, so this is all good, right? We have a huge game board with all kind of players are running, and then the reason we want to do a benchmark is because we want to make sure we start with a known state. We could control the sequence. We could repeat it so that the benchmark will make sense, right? So we do that, and then perhaps we could actually look into. We'll keep it like this, and we'll talk. We'll go back to this game a little bit later. So, what's the nature of this game? And then let's actually just use a little flow diagram to describe it. So it actually has a bunch of players, matrix of players. Each player has a set of 4 directions: north, south, east, and west, right? That's how you rotate 90 degrees. And then it's touch-enabled game, so you touch every player. That player is going to generate a list of neighbors. You're going to touch your neighbor, do a high five, right? And then you're going to actually create that particular list, and your neighbor is going to create its own list. So it's actually like a little domino, and you could actually generate a huge list. So rotate the player all the time until you repeat until that all the neighbors list is empty. So that's actually what you sort of deal with. You see that from the game I showed you earlier. Now, obviously, this is a casual game. It's one page. It's relatively simple. But there's a lot of things we actually used here. We used intensively of arrays, right? Think about all the list of players, We use the objects with the properties, at least the 4 directions. We use the numbers a lot because we really have to calculate use all the math to calculate all the direction, to calculate all the rest of the detail. We do use animation loop because it's repeating until the list is generated. So in general, we use quite a bit of memory allocation, right? So this is something, which is very important early time. We talk about memory allocation. This is all tied back to this particular case study. Okay, so actually, if you look at the next slide, we actually have a little benchmark. This is actually the data from F12 UI responsiveness, and it looks like the throughput is very has a lot of depth, and it's not smooth at all, right? Most of the time it hit 30, and only a few hit 60. Okay, so we could take a quick look to see the game, and we actually use let's do F12. And let's actually hit it and take a little data. All right. I'll take a few rotations. And then again, this UI responsiveness tool is going to tell us, how good is our data. Okay, so we actually do have a lot of dipping here and there regularly, and we're not seeing very smooth or what we call fluid kind of response. The ideal case is obviously everything should be 60 frames per second. That's a perfect score. But sometimes you may not achieve that. But at least you don't want things like having so many little dip up and down. So it's actually going to you will find that the user experience is not that nice. So the other thing we look into is we see its CPU utilization is actually quite busy. We see a lot of starring. We see a lot of things really going on. We see scripting. We see quite a lot of yellows here, which means it's garbage collection really going on. So if we take a little close look of this piece of garbage collection. Okay, let's make it a little larger. And then zoom into that. Just like JD told us, right? Know how to do that. So we could actually see quite a bit of garbage collection happening, like pretty
on the
frequent.
foreground thread too.
Yes, exactly. Let me actually enlarge this particular one, and then you could see actually garbage collection is really takes quite a bit of CPU here.
Can you do me a favor and see what the background thread is?
Exactly. So I was going to show you. This is let's actually give a little duration time, and then based on the filter, we can actually see the background activity.
Ah, nice.
All right.
Okay.
So if you look at this particular one, this is actually a UI, not a UI, I'm sorry. This is a garbage collection thread. Has a thread, a particular number. So it takes about 7.95, right? And then obviously you see there's quite a bit of garbage collection going on. So again, if we could actually not seeing the background garbage collection thread, but then even by just looking at all those particular thread, like what do we see here? Let's see if we have any particular garbage collection which will block the UI thread. Okay, so you could see this is actually, a very small piece of data, and you will see this is actually running as sharing with the UI thread. Mm-hmm. So it is actually a garbage collection, even though it doesn't really take extremely long. But hey, every bit's really accumulated, and it does show there's quite a bit of garbage collection going not on the background but on the foreground, and then it does block the UI thread. Okay, so this is sort of like a good hint, sort of to look into to see if the garbage collection take place too often than we would expect it, right? So because of that, let's actually go back to take a look our code to see if we have a better way of looking into that. Okay, so before we do that, we could take a look. Little nicer diagram. This was showing you use a performance tool to plot to see how this garbage collection happening, and then more focus on garbage collection and how does that refer to the CPU utilization. And this is really showing all the garbage collection, and that's quite frequent, just like what we observed from the F12 UI responsiveness too. All right, so that tells me something, right? So one thing I'm gonna use the rules, actually principles that JD just talked about in the previous module is one rule is stay lean, right? If I have too much garbage collection going on, that means that might be something I'm doing which is not that right?
Too much foreground garbage collection.
Exactly. This is that's a very good point. It's not just background. Background is probably okay, but foreground, especially you see attached with the US thread, that's a foreground garbage collection. This is really going to slow down with creating the pause, block the US thread, so you will see the performance degradation on that point. Okay, a few things we examine. We could trigger a garbage collection, right? So it's, you create a call and to a new implicit memory allocation, right? And then every call you want to create a new object, it's very likely you can actually trigger the garbage collection if you create enough new objects, which is maybe not that necessary, right? And
this is a bit of review because this is something we covered in a previous module.
Right.
It still holds true, especially for this game.
Very true. And we want to look into our code later on to see if we create too many new objects, if we are leveraging the object pool, if we actually doing things like if we could simply change the property, then we should just do that instead of create a new object. So all these things we should actually look into our code to see if those trigger the garbage collection. Okay, so let's go to our code, take a look. All right, so obviously this is not a super long kind of code in HTML level, but what we want to take a look is JavaScript, right? So we want to actually examine a few things. The first thing I think I want to really look into is a new object creation, okay? So let's actually take a quick look. So we have a few array and a new object for the matrix, for the players. We have a temporary matrix to fit into intermediate data. We have the benchmark arrays, which remember we said we turn on the benchmark. We want to start at exactly same state, a known state, and keep the sequence going so we could take the meaningful data for benchmark. So we have some arrays which is associated with that. And if we go through and we see there are two types of players. One is Judy, the other one is Mir, and both of them is actually using the player as a construct to actually create the player object. So we could actually take a quick look of their player. And then we could save it for later. Let's actually continue. So still continue with create a new array for this particular matrix. And then
I notice it's pre-allocating the array size too.
Yes.
Based on board size.
That's
using
true.
Some of the tips from earlier.
Right. We already take advantage of some of the tips already when we write the initial code. And then here is you actually you fill the try to fill the board with other players from the known orientations. So you actually create a new player to fit in this particular matrix based on the particular the directions, right? 4 directions as your property. Okay, so this looks okay. And moving on. We will see we're actually here. Okay, here's interesting. So we try to fill this matrix with the players, right? And which is we try to leverage the object pool, right? So in this case, we create our different Judy and Mir with a particular new object, right? And then defining their properties based on their direction. Okay, that's initialization. So that looks okay. And moving on to the next level, which is, okay, so, this is something we want to actually take a little close look. This is when you try to commit that rotation when you hit 5 and rotate it 90 degrees. And each player will be rotate, and they will update a matrix, right? So the way we do that is we actually, create a, say, for example, if it's a player is facing northeast, and then we will actually try to actually say the next step is southeast, for example. And then we actually, instead of actually try to fit into change the property of that, we actually create a new object. So this might be something has room to improve, right? So that's one area. So the other area is after we commit the rotate, update the matrix, we actually want to rotate 90 degrees. Okay, so this is the time, what we see here is we actually, we're changing, we're facing northeast and all those things. Sorry, which is here. We're facing northeast. We're actually creating, hold on, let me actually go to the previous one. So, okay. So we talk about this is a room for improvement. And the other one we want to actually say is inside of this, when we commit rotate, and we're doing a true rotate, and then we actually, what we do here is we actually checking if that player is facing north and east. We actually update the property, right, from northeast to east-south. That's the next step. But instead of using just the full property north, east, south, all those, we actually introduce another one called east-south. Right? And then if you look into that, and you may want to think about, is it absolutely necessary? We want to have northeast, or southeast. We introduce another property in addition to the 4 directions here. So that's something we could think about, right? But this is in the current implementation, we did this way. Because if you think about the whole thing, you're doing, say, northeast, it says this, and then you're doing the other direction is southeast, but your east is not changing. You only change from north to south. These 2 properties needs to be updated. So you could actually think about it would be a better way of doing it is just keep the same 4 fundamental direction without introducing northeast, southeast, southwest, west, north, and so on, right? So these you should use a pool, you should use existing property as much as possible. So this is basically something, 2 suspicious plays we look into, and we try to do some better job on that.
So say we didn't know about those problem areas. We could use F12 profiler to detect the function execution, and those 2 functions would probably bubble up to the top as being very expensive. And then from there, we could dig down into that and look at them.
Exactly, because the first indication is garbage collection. We see a little abnormal behavior of garbage collection, which has happened too often and in the foreground. And then that's why we look into the new object creation in our code. We found some of the suspicious kind of area which has room to improve. Then we dig into that to see we can make it better. Okay, so so fixing this, so how do we do that? So first, so we fix the rotate from creating additional all the object by actually using the pool, and then actually push this either north or south into this particular one instead of using the previous property like northeast or southeast and all those things. So this is basically just updating all the properties there. Next, what we do here is for the commit rotation, that part, we actually not to use additional new property and not to create a new object. We just recycle all the particular node which contains a direction for the property. We just reuse that again. So that way we could actually reduce some of the object creation as well as object assigning. Right? So let's actually go back to the code to fix it. So we have 2 fix here. Oops. And then we actually, first of all, we want to fix this commit rotation. We want to call it faster. And the other one, we want to call it rotate. That's another method we look into, right? We want to call it a rotate faster. Okay, so we did some change here. Let's save it. And let's try to run the code to see if it's still working. All right? So let's do a shift.
Live demo time here.
Live demo time. Yeah. Cross the finger always. Yeah. Okay, so we actually, again, we let it run. Okay, let's first try it. Okay, seems like the fix did not break the code. All right. Like we said, nice. Should be still maintainable. And then we increase the size, and then take the benchmark, right, and try it. It looks like still working properly. Okay, let's take the F12 tools, and let's actually capture the data. And I usually just let it run. This is the benchmark, so we could see when the high five is going to 5,000 level, then let it run several iterations, so we could take some statistics from it. So that's what we do. All right, so we click on that, and we stop the profiling, and hopefully we see some response back. Okay, so we actually see the UI response seem like it still need room to improve, still has a little dip here and there. But when I look at the garbage collection, the frequency of happen all the garbage collection, it looks like it's less little yellow bars here. It's not as frequent as before.
Can you scroll down to the pie or to the other chart that shows, if you scroll down just a little bit, you'll be able to see there it is. Yeah. There's the circular. How much is that? So not much at all. Right.
So it's kind of like it's 0.16, you know, and then versus. But if you look at some of the most expensive, if you look at like just one bar, I remember there are like multiple bars here. If you're looking to just zoom into how frequent the garbage collection takes place and look at it, and you will see it is actually less frequent if you take a time frame like this. And so we did, reduce some of the garbage collection by reducing some of the new object creation. And obviously, it's not going to change in the whole garbage collection. It might be still something, still room to improve. That's very possible. But we actually use a tool to actually measure the improvement. And this is a benchmark. Again, it's our benchmark. And we look at that and we see the overall foreground garbage collection time reduced to 1/3, and the raw JavaScript performance improved by 3 times. So that's another piece of data. We actually use a performance analyzer. So this is pretty good. So stay lean in general, it's working. It's in the good direction we want it to be, right? It has a less garbage collection. And okay, so this is something JD talked about that before, but then just to go back, it's truly, we should avoid creating unnecessary object, right? Like a new object all the way there. Aware of the allocation patterns, right? And then removing all the event handler if you don't need them, reducing the intermediate objects, and then all the implicit allocations in the engine, you should really watch out because that's actually engine is going to getting a lot of unnecessary object to work with. And by showing this step in the code, and we actually did follow the guideline best practice to make our performance a little better. So next is talk about using fast objects and manipulations. So let's go back to the implicit allocations in the engine, that last statement, right? And this will lead to another best practice we want to share with people, which is work with fast object types. Okay, so when you actually see the internal type system, you have your fast object types. And this is for any of the engine, they actually will start with base type, pretty empty. And then you actually going to fit into your first property, north, right? And then you have another property called south, right? And each one of them with different property 1 or 0. So that's one object you created, right? And then let's look into the next. There's another object you created. And then you actually assign the property to south first and then next to the north.
Right, so this has to deal with property layout. The values don't necessarily have to be the same, but it is important the order in which the properties are assigned. Mm-hmm. Or if it's an object literal, the order in which the properties appear.
Right. The
property layout. Some engines call this a hidden class. Mm-hmm. Chakra calls it a type. Others may call it a shape. Mm-hmm. But it's all talking about the same thing. It's how the object is represented behind the scenes sure. And the layout of the object.
Right. Right. So if you look at this particular two variable, P1 and P2, I want to ask you, do you think P1 and P2, they are the same type object? They're the same? Somebody say yes, somebody say no, right? And then as a matter of fact, they are not the same object type. right? Because the order of the property inside of that particular P1 and P2, they're different. So for the compiler, they treat it as different object type, right? So even though you thought, oh, the property content seem like very similar, right? North and south, but then, yeah, actually they're
not. This has to get into optimizing property access, polymorphic, monomorphic property access, inline caches. Basically,
which you will talk about in more detail.
If you have an object that is, if you have consistent types for your object, so backing types, the engines can optimize for that to have faster property access. So just as before, where we were talking about type specializing based on ints and floats and strings, in this case, having objects with the same layout will give you faster property access than having and providing objects to a function with different types.
Very true. And then second thing is do not add a properties conditionally. Okay, I don't know if you ever done this. I actually did it before.
I do this too.
So, okay, so we thought it's, in this particular case, it's very natural, right? We're checking the direction, see if it's northeast and east-south, right? So we use a condition in the constructor and then assign the property accordingly, right? So this is how we do that for our player on the red area. And then you will actually have, you actually create a two variable, for example, P1 and a P2 with the different properties, right? And then if you look into this object type, you will think these two are the same kind of type because we just use a little condition to checking, but the type is pretty much the same.
They're the
right?
same instance, right?
Right.
I mean, well, they're not the same instance, but they're of the same constructor.
Exactly.
So they're the same
so
instance
it must be the
of,
same, right?
But in this case, behind the scenes, they're two different types.
Right. They are actually two different types because you use a conditional kind of checking to do that. So compiler has to, say this is not the same data type we're working with. Okay. So if you want to make sure you get the consistent kind of data type, it's the same data type, then do things in the right-hand side, which is go to that code. And it has the green area shaded. And it's very simple. This is basically just a player with 4 different directions. And you could play with a property to indicate if it's northeast, south, and so on. So just do this. Simply just do this. Assign them. And then P1 and P2, they will be the same object type. In that case, compiler doesn't have to implicitly allocate a different type just because they thought that they are different, right? So this will save a lot of resource and it become more efficiency. Again, I think I have mixed feeling about prototype actually. Okay, this is an example about a prototype. If you actually look into this particular example, people use prototype and try to initialize that particular state at the beginning to initialize it. But maybe you don't know, compiler is not won't be able to see what exactly the type for that player through a prototype. Compiler couldn't really, go on the top and figure out that. So because of that, all the variable you actually created, it's going to be a different type for compiler because they could not go through prototype and figure out the original type. So if try to not use default properties on prototypes, you have to be really careful about that.
Right. You can keep methods on your prototypes, but in this case, assigning the default properties, especially if you're mutating them afterwards. So in this example, in the slow case, P1 is assigning in and P2 is assigning e. It's creating 2 different types for those objects, even though both have values of in and e on their prototype. Setting the own property on the object does create a different type.
Okay, so what would be better way doing that? It's on the other side, right? So when you see the slide, you will see just simply initialize it without a prototype. Just assign the initialize their 4 directions at the beginning, and then the compiler look at that and will say, oh, I know what is the original object type. Then all the P1, P2, P3, they will be the same object type. So this would be a much better way of doing things. So moving on to the next one, is actually, you could see that you want, again, classical example,
Here's delete.
Okay, so like we said, you probably would have guessed, okay, do not use delete. Very true. Again, avoid using the force conversion type from the fast type to the slower type, a slower property bag type by, just keep on using delete. You could simply just using something like 0 or null, to do the job.
Right. Since you have this type, this object layout for properties, and then you use delete, just destroys that type for that object, and then of course it does make it the slower property bag for that for the lifetime of that object. So delete again. If you don't need it, don't do it. I mean, there's really if you can avoid it, just avoid it. Use null, use undefined. It's going to preserve that type because again, type isn't related to the values in it. So where there is other optimizations about type specializing. In this case, we're talking about the internal layout of the object. So it's not really the value type; it's the layout of the properties. And so if you can preserve that, you'll have faster property access.
Very true. Okay, so again, this is another one which is on top of, avoid creating slower property bags. So you have a prayer in this case, and then somehow you think there are 256 properties you need to assign to it. I don't know if it makes sense. You have a prayer have so many, over 250 properties, right?
So you'll see this a lot in like large data. So if you're dealing with plotting points on a map or receiving a large JSON data object, you could have objects with lots of properties. Now the thing is engines at some point have to say, we can't handle that, and so the heuristics vary by engine, but keeping your objects small will help keep them having the fast property access, because at some point the overhead for all of the caches and fast property access is too much because of the sheer number of properties you have on the object. So in general, keep your objects lean on properties as well. So just as reducing your markup and keeping clean markup and DOM helps the DOM, keeping your objects clean and having avoiding extraneous properties can also help you hit that fast path for property access.
Exactly. So you need to restrict to a few of them. In this case, it's only 4 directions. So naturally, it's just 4 properties instead of over 250 property, because it's going to really slow down the whole thing. So just restrict it to a few, you could handle, and then that would be much more faster. And then, this is a good example. Now, I know we all appreciate the effort of ECMA 506 and show you what would be a better way to writing maintainable code, including how to really do get and set, enumerable kind of a way of go through your object. Now, this might be, in a way, it's good, but if you're just showing maybe once or twice, maybe it's no big deal. But this particular player is going to be working, in a loop for over million of times, so it's going to actually cost you eventually, right? So instead of just going through, restricted using all try to use all the get set, all the property, you should think about it. Just do something very simple. In this case, it's just assigning the property northeast, southwest to it instead of going through all those things, So that way, this approach in the green area would be much more faster.
So with IE11, we were able to optimize in an inline getters. And in the next version, we will be optimizing and inlining setters. But still, having to optimize them versus not having to optimize them and having to just use a simple property, you will get faster results. Right. That said, we are aware that if you're dealing with object-oriented patterns, getters and setters sure are friendly and make working with your code a lot easier. So in this case, it's perf versus convenience.
Right.
And so getters and setters make working with your properties convenient, but in this case, there is some overhead associated with it, even when engines are optimizing. So in this case, in this perf critical path, you could simplify that by just using vanilla properties, and you'll get better performance.
Sure. Okay, so we actually have a slide talk about the impact of inline caches, and I think
sure, I'll take over
knows a lot better than
this one. So if you're dealing with a function, then you're passing it objects of multiple caches or multiple types. You'll have slower property access because first it will say, hey, I don't have this inline cache created for this object, and so then it has to create that cache, do the property lookups, and so there's overhead associated with that. And then the next time you call the function, so this is if it's being JITted, the next time you call the function and you pass it an object of a different type, it says, it just created this cache for the previous type and did all this optimization work, and then you're saying, oh, by the way, this is a different type, and so it has to do the same thing and create a polymorphic inline cache. So there's overhead associated with that there. Whereas if you stick with objects of consistent types, it will create the cache once and have it optimized for each subsequent call to that function. And so this chart here shows that the original time was pretty slow, so like 12 seconds, and then it was reduced to below 8 seconds, so just a little over 4, and then with the fast cache and objects and with caches, it was less than 4 seconds. So substantial performance improvements by utilizing consistent object types behind the scenes to create faster property access.
Great. Okay, so let's actually go back to see if we could fix some of the code in the casual game and to make it run faster. Okay, let's go back to Visual Studio. We're showing, okay, so two things sort of catch our attention is it's the way we create a player. One is we actually did use a lot of get and setter enumerate kind of type to construct this player. The other way is just using assigning full properties for the direction, and very, very clean and slim to look at. So in the first one, we actually use this getter setter enumerable kind of way to do things, and now we're going to actually change it into the simple way, and also hopefully is a fast way to do that. So it's called a fast player. Fast player. Again, this is actually how we actually create the players, two type of player. Okay, so let's actually quickly run it to see we did not break anything. So that's good. Looks like it's still running. Performance optimization is like that. Every time you do an idle thing, you want to make sure you don't break the code first, and then see if you could make something better. All right. So time-wise, I'm actually going to go back to my slide and show you some of the result. So what we see here is from this benchmark says this is pretty good. We're actually reducing the execution time from 3.8 seconds to 2.2 seconds, which is almost 30% reduction in the JavaScript by using the very simple way to do the constructor instead of using using fast object instead of using get and setter.
Right.
And then I'm sure, when we have a next version of JavaScript engine, Chakra, we even could see better JavaScript performance. Okay, so really the script time in the script reduced by 30%, and then the raw JavaScript performance also improved by 30%. And then this is pretty good, and this is something we're pretty proud of. Having pretty fast engine. We could really improve the performance by that much.
And these tips apply to other engines as well.
Exactly.
I mean, if you have consistent types, your JavaScript engine is going to benefit from that, and you are going to get faster property access. So this goes across engines, not just IE or Chakra specific.
Very true. And then best practice we need to follow is create and use the fast object types. Keep the shape of object consistent, right? Because otherwise you create a lot of implicit object types for the engine. Avoid type mismatch for the fast object types, and avoid inline cache misses. All right. So these are the things we need you to apply for your code. Okay, so we've done a lot of memory allocation fix, JavaScript engine, JavaScript fix. Now let's actually look into this little do less work, which we actually touched about that before. So it is really a review. We will look into the code to see if there's any intermediate DOM object we created and it's really too much. We should cache it, right? So we just talked about it in the previous module. We're not going to go over the too much detail. And also in this case, it's border size is integer. So make sure you use a parse int to to make it a border size as integer. So this is something we already see. We want to check if it's implementing the code.
Now, this is something that comes up in DOM quite frequently, is when you get a property from a DOM element, it likely will be a string. And even if it's a number, it's a string. So like, it'll be a string 1 or a string 2. And so when the parse int there, that function parses it and turns it into an integer for you. There's also parse float, so if you want, you can create a float, but we all know about floats from the previous chapters, the previous modules, that they should be avoided. So you could coerce this to an integer and make sure that you're always working with the integer. The engine will be able to type specialize and work with those values in a more performant way.
Right. So the other thing actually JD actually talked about is know what your code is execute, right? Do less work. So again, we're going to actually, we first actually start to use a set interval, set a ready timeout. And then in that case, we leave the interval and timeout is 0. 0 means keep on changing, no intervals,
set
right?
Timeout 0 should absolutely never be used.
Right.
Just avoid it completely. Older browsers would actually lock up the UI thread with that too. So no. Set timeout and set intervals, zeros should not be used. In this case, the next example of a set interval having 1,000 divided by 60 will get you close to that 60 frames a second, but even then, if you have a request animation frame, use request animation.
Exactly. Much less work, and leave the browser to determine what will be optimized interval. So you don't have to worry about that. Okay, so looks like we have some new things to work on. Okay, let's actually go back to the code again. Okay, and then let's actually find out. There are a few things I could look into. One is I'm actually, because we want remember we want to do the benchmark. So we actually did quite a bit of work. If you look at our copy method at the beginning. Let me try it one more time. You will see because I want to do the benchmark, started with a known state, we actually did a lot of really CSS kind of manipulation, changing, and it's going to spend a lot of resource on doing that, right? So this is something we could say we don't really need to start from really the benchmark, because benchmark has a little overhead, right? We could actually remove that the way of doing benchmark, and then we actually could just leave it using a natural way, which is using the random generator to generate all the node, what's going to happen next. So this is the first fix. Second one is we have a timeout method, and we look at that is we actually set up the timeout into 0. Interval basically means is keep on changing things, nonstop. And then what would be a better way of doing that is obviously, like we learned, use request animation frame. Leave the browser to determine what would be optimized time interval to call your animated callback routine. Okay, all right. So we have a new fix, and let's try to run this program to see if it's still working. Okay, let me actually quit this. Clean up, run one more time. All right. Seems like it's still working.
All right.
And let's actually increase it and do better work. Okay, so let's actually hit the F12 tools and start profiling. Like to go a few sort of iterations so that we get enough statistics. And then, wow!
60 frames a second.
How about that?
Right.
Look at that.
Yeah.
Well, there's always some room to improve. There's a little dip, tiny bit. But compared to the previous case, you see a lot of huge, unevenly distributed UI responsiveness, and this will be actually much, much better, right? Isn't it? And then by applying a few techniques we learned, and we actually could really make the performance and the UI responsiveness a lot better. So, pretty happy with that, huh?
Yeah,
and then
awesome.
You could actually access the code, the JavaScript code in the GitHub, and you could actually play with that yourself. So, from a better statistics, we could see by using compare the set timeout versus request animation frame, we increase performance from reduce it to 65% from the 75%. So that's quite a bit saving on the CPU cycles. And then when we see problem resolved, everybody's happy. And then what else is we actually provide a better user experience. And because we use less CPU, remember CPU, GPU, all the UI responsiveness, all contribute to our battery life, to the power consumption. So go back to the things you learned at the beginning. It will help you to have better battery life when you're playing this game. So everybody will be happy. Because you're saving about battery life, you could make running all the other apps at the same time. So make your apps richer. So this is really a case study or a benchmark. And the Checkra team actually contributed. And then this is really a good one to look into to understand why all those things we talk about are so important. And this is a really step-by-step tuning. So in summary, we talk about how to stay lean, right? Check the garbage collection, checking all the new objects if we're creating too much. Use the fast objects, do fast manipulation, using simple property assignment instead of using things like get and setter, enumerate. Do less work, watch out how often you actually invoke your callback routine. Try to use request frames and try to think about if there's something unnecessary. For example, like what we show here, the benchmark. Right? It is good for us to keep the same sequence with a known state for our benchmark. But then in real life, probably you have to think about it if that created a little overhead onto it as well, right? So you could always play with the benchmark, figure out what's the best way in your production environment. That's a key message. Okay, so before we wrap it up, we basically want to share with you some of the resources which you may find useful. Some of the overview concepts, say if you're totally new to this web performance tuning, Steve Sauter's book, High Performance Website, Even Faster Website, these two would be a good beginning kind of course for you to look into to get some idea. And there's another one called High Performance Browser Networking. It's also not bad to look into. If you are kind of person really want to learn how to write a good JavaScript code, get into the JavaScript pattern, then the few books like the High Performance JavaScript, Doug Crawford book is pretty popular. It's called JavaScript, the good part, the bad part. So it's always good to look into. And there's some JavaScript pattern. If you want to learn, you could always learn that. Script cookbook, in case you want just a cookbook style, you could always look into that. Okay, this is for the generic resource. So let's look into the Microsoft more detailed guidelines, especially for Windows app. There's a JavaScript best practice. If you're writing a Windows app using HTML, JavaScript, highly recommend you to look into what are the best practices are there. And another interesting one to look into is Internet Explorer Architecture Overview. JD actually talked about all the runtime, infrastructure, different step detail. But if you want to know more about that, this is an article you should look into. And again, we actually have quite a few PMs at Microsoft work with W3C web performance. So it's very resourceful. They have a lot of good specific timing specification working group. If you're really interested and want to contribute and give your feedback, this is a good place to really look into. Blog posting is always good, right? So there's a most updated one will be some of the key advantages to JavaScript performance in browser.
I helped write that blog
post.
Yes.
So JD probably have more to share with us.
If you're wanting to see what's coming with, in the Chakra engine and the advancements that we're working on, you can check out that blog post. It talks about some of the optimizations mentioned here about inlining setters, hoisting bounds checks and length loads, and various other optimizations, as well as pushing more things to alternate and background threads. So it's totally worth the read. Check it out. Anything else you want to say about these resource links?
No, it's actually very good. Go back to the blog posting that slide. You will actually see there's also article measuring the browser performance in the lab environment, as well as common benchmarks. What do they measure? You want to get more ideas, And then the tools, right? We talk about how to use F12 tools, but if you want more documentation, look into the last link. And also, we didn't really have room to talk a lot of detail in Windows performance tools. If you want to use them, you could actually go through this link, and it shows you step by step how to do that. And with that, I want to actually just share with you the resource one more time. This is where you get the most updated slide deck. And again, all the demos, all the demo scripts actually posted on the GitHub. You could take a look. I think, it's been a long day, and I think that's all from us. And I want to thank you very much to stay towards the very end. You have been great audience. I also want to thank you, JD, to join me for this course and provide a lot of real-life experience and the product team insights to that, really definitely adding huge value into it. I also want to thank you, Chakra product team, to give a lot of support for this course so that you could have such a high-quality content there. And one thing to remind you, do not forget to do the poll. It's underneath this streaming. Try to give us some feedback. And again, you both know the content information. By downloading the slide, you could see JD's and mine, and feel free to give us feedback. And I want to thank you very much, and I hope to see you in some other MVA courses.
Sure, I think we should end this with a high five freeze frame.
Yay!
High five freeze frame.